Assalamu alaikum. Here is a question I want to sit with you for a moment. Why do some students seem to learn effortlessly while others struggle with same material from the same teacher in the same classroom? For most of human history, we explained that difference by talking about the ability. Some children were simply smarter, more gifted, more capable. But cognitive science, the science of how the mind works, tells us something different, which is fundamentally different from our idea. It tells us that learning is not a fixed gift, it is a process. And like any process, it can be understood, supported, and dramatically improved. I am Ijaz Ahmed, a researcher in education, and on this channel, Education AI Parixes, I translate the science of learning into practical teaching strategies. In this video, I want to give you a clear, teacher-friendly picture of how brain actually learns and why understanding this changes everything about how we teach. In next 10 minutes, we are going to cover 4 fundamental ideas from cognitive science that every teacher should know. I will explain what each one means and why it matters for learning and give you a clear classroom implication for each. These 4 ideas are how memory works, the role of working memory in learning, the importance of prior knowledge, and how practice builds long term retention. Together, they form the foundation of what researchers call science of learning. And once you see teaching through this lens, you will never plan a lesson quite the same way again. Concept number 1 is how memory works, the two-store model. Let us start with memory, specifically a model that has shaped our understanding of learning over the past 50 years. In simple terms, information enters through our senses, passes briefly through working memory, and if processed deeply enough, gets stored in long-term memory. That journey from sensory input to long-term storage is called learning. Long-term memory, remarkably, has virtually unlimited capacity. The human brain can store an extraordinary amount of knowledge, facts, skills, procedures, experiences. The challenge is not the capacity. The challenge is getting information there and being able to retrieve it reliably when needed. Why does this matter for teaching? Because many of our classroom practices are designed to help students in the moment, but not necessarily to transfer knowledge into long term memory. Understanding this model helps us design lessons that do both. Classroom implications of this idea is that build your lesson with retrieval practice. Ask students to actively recall information rather than simply rereading it. Every time a student successfully retrieves a memory, that memory becomes stronger and more durable. We will dedicate a full video to retrieval practice in this series. The second concept is working memory. This is a bottleneck for learning. Now, here is the part that most teachers find genuinely eye opening. Working memory, the mental workspace where conscious thinking happens, is severely limited. Research by cognitive psychologist George Miller famously suggested we can hold roughly 7 pieces of information at once. More recent research by Nelson Cowan puts it even lower, closer to 4. Thinking about what this means in your classroom. When you introduce a new concept, students are using working memory to process your words, hold the new idea, connect it to that which already know, and make sense of any supporting material, all at the same time. If any one of those demands is too heavy, the system becomes overwhelmed. This is what cognitive scientists call cognitive overload. And when that happens, learning stops. Classroom implication: reduce unnecessary cognitive load in your lessons. Present one idea at the time. Break complex tasks into steps. Use visuals to offload verbal information. Break complex tasks into steps. Use visuals to offload verbal information. Remove distracting elements from your slides. Every bit of mental effort you save on irrelevant processing is energy available for actual learning. The educational psychologist David Asubal once wrote something that has stayed with researchers for decades. The most important single factor influencing learning is what learners already knows. This is not an opinion. It is one of the most consistently spotted finding in all the cognitive science. New knowledge does not exist in isolation. It attaches itself quite literally in terms of neural connections to what is already stored in long-term memory. This means that a student who already has rich background knowledge in a topic will learn new related content far more easily than a student who does, not because they are more intelligent, but because they have more anchor points for the new information to connect to. This has profound implication for equity in education. Students from knowledge-rich home environments where they encounter a wide vocabulary, varied experiences, and rich conversation arrive at school with significant learning advantage, not a fixed one, but one we need to deliberately address through our teaching. Classroom implication: begin every lesson by deliberately activating prior knowledge. Find out what students already know and build from there. Then students lack background knowledge. When students lack background knowledge on a topic, invest time in building for it before introducing the new content. It is not wasted time. It is the foundation that makes everything else possible. The final concept is perhaps the most practically important: how practice builds lasting retention. The 19th century psychologist Ebbinghaus discovered something we now call forgetting curve. The finding that without any review, we forget roughly half of new information within an hour and up to 80% within a week. But here is the crucial finding: every time we retrieve and review information before we have completely forgotten it, we reset the curve. We slow the forgetting, and over multiple retrieval sessions, the memory becomes progressively stronger, more stable, and more resistant to forgetting. This is the basis of what researchers call spaced practice, one of the most powerful learning strategies we know of. What this means practically: reviewing last week's content at the start of this week's lesson is not revision, it is consolidation. It is strengthening the neural pathways that make knowledge durable. A 5-minute recall activity at the beginning of class is not taking time away from learning. It is learning of the most powerful kind. Combine spaced practice with retrieval, asking students to actively recall rather than passively reread. And you have two of the most evidence rich learning strategies available to any teacher in any subject at any level. So let us bring all these four ideas together into a simple picture of how learning works. Information enters through working memory, which is limited. So we must manage cognitive load carefully. It connects to prior knowledge. So activating what students already know is not optional, it is essential. And it becomes permanent through spaced retrieval practice because memory is strengthened every time it is successfully recalled. This is the foundation of evidence informed teaching, not a set of tricks or gimmicks, but a principled understanding of how human cognition works. It means how we design learning experiences. यानी ये जो चार बातें हैं जिनमें के हमने ये जिक्र किया, वर्किंग मेमोरी का और प्रायर नॉलेज का, और हमने जिक्र किया स्पेस्ड रिट्रीवल का, ये बहुत ही अहम मौज़ूआत हैं जो कि बुनियाद फ्राहम करते हैं, जो कि रिसर्च ने और रिसर्च बेस्ड एविडेंस ने ये बातें हमारे सामने रखी हैं. दिस फाउंडेशन ऑफ evidence informed teaching, not a set of tricks or gimmicks, but a principled understanding of how human cognition works and what means for how we design learning experiences. Here is your action step. This week, choose one of these 4 insights and look for evidence of it in your own classroom. Where do you see cognitive overload happening? When do students struggle because of missing prior knowledge? Where could a 5-minute retrieval activity make the real difference? Leave your observation in the comments. I read everyone. If you found this useful, please subscribe. Every week, I bring more evidence-informed strategies for teaching and learning. In the next video in this series, we go deeper into one of the most powerful ideas from cognitive science, the retrieval practice, how it works, why it works, and exactly how to build into your daily teaching. I will see you there.